Decorating class methods with @MCP tool seems straightforward until you discover the decorator order completely changes whether your code works or silently fails. We'll see exactly what happens when you swap the order of @class method and @MCP tool, and why FastMCP deliberately raises an error in one case but stays quiet in the other. The key difference lies in how Python binds the method before FastMCP even sees it. From FastMCP, import FastMCP. MCP equals FastMCP. Class myClass. @class method. @MCP. Tool hash this won't work but won't raise an error. Def from string v1, CLS_s. Return CLS_s. @MCP tool. @class method hash. This will raise a helpful value error. Def from string v2, CLS_s. Return CLS_s. This demonstrates the post-binding registration pattern for integrating class methods with decorator-based frameworks. The core concept is separating method definition from framework registration, ensuring proper binding of self or CLS parameters before exposing the method as a callable tool. What makes this distinctive is its explicit handling of Python's method binding system, rather than fighting against it with decorator stacking. The pattern works by leveraging Python's late binding behavior for methods. Instead of decorating methods at definition time, when they're unbound, you register them after the class or instance exists, when Python has already performed the binding. This maintains clean separation between your class design and framework integration, while ensuring the exposed interface only shows the parameters an LLM or client actually needs to provide. This approach solves the common problem of framework decorators breaking method binding in object-oriented code. It's particularly valuable when building AI-integrated systems where you need to expose class methods as tools without leaking implementation details like self or CLS to the caller. The trade-off is slightly more explicit registration code, but the benefit is reliable behavior and cleaner abstraction boundaries between your domain logic and the framework layer. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It transforms Python functions into structured tools that AI models can invoke, handling serialization and schema generation automatically. MCP equals FastMCP. Instantiates the FastMCP client, the central entry point for registering AI-callable tools. This instance manages tool discovery, schema generation, and execution routing between Python and AI models. All tool decorators require this initialized client. Class myClass. Defines a Python class named myClass, serving as the container for our tool methods. This establishes the namespace and enables class-level operations like @class method decorators, which we'll use to create alternative constructors. @class method. @MCP. Tool hash this won't work but won't raise an error. Def from string v1, CLS_s. This applies @MCP tool after @class method, which silently fails to expose the method as an AI-callable tool. Decorator order matters. @MCP tool must wrap the method directly to register it with FastMCP's tool system. Return CLS_s. This instantiates the class using the input string, returning a new object of the same type as CLS. In class methods, CLS_s is the standard pattern for creating instances from alternative constructors, ensuring consistent object initialization regardless of how the class is invoked. @MCP tool. @class method hash. This will raise a helpful value error. Def from string v2, CLS_s. This applies at MCP, tool first, then at class method, which triggers FastMCP's validation. The decorator order matters. This ensures the tool is properly registered as a class method, preventing silent failures that could create unusable AI-callable tools.
Return CLS S.
This instantiates the class using the input string, returning a new object of the same type as CLS. In class methods, CLS refers to the class itself, enabling this pattern to work as an alternative constructor. The decorator order above determines whether this method remains AI-callable or becomes a standard class method. FastMCP decorator order. The @MCP tool and @class method decorators interact in subtle ways, where order determines whether you get silent failure or helpful validation. Placing @MCP tool after @class method creates an unbound method that appears to work but fails during execution. Always register class methods after class definition to ensure proper binding and schema generation.
The decorator that comes last serves first.